this video, let me explain what is automata theory and the basic notations that we are going to use in finite automata. Okay, now let me start with what is symbol first. A symbol is an abstract entity that we shall not define formally, just as point and line that are not defined in geometry, isn't it? For example, letters and digits are examples of most frequently used symbols. Letters means either you can take A, B, C, that is in lowercase, okay? Whereas in terms of digits, you can take 0, 1, 2, 3, etc. Okay? So, a string or word is a finite sequence of symbols juxtaposed. Okay? So, for example, A, B, C are symbols, isn't it? And A, B, C, B is a string. Like that, you can form one more string too. A, B. This is also a string. Also A, B, that is also a string. Okay, so you can form different kinds of string from the symbols, right? The length of the string is denoted by omega and is denoted by absolute omega. That is the number of symbols composing the string. For example, ABCB has length 4, which means that consists of 4 letters, so that the length of the string is 4. So the empty string is denoted by epsilon, and is the string consists of no symbols, that is 0 symbol, so the absolute epsilon is equal to 0. Next we move on to an important thing, that is alphabet and language. So an alphabet is a finite set of symbols which is usually denoted by sigma. So sigma may be consist of set of symbols of either in terms of letters like A, B, C, or it can take digits too. Set of 0, 1, 2 or 0, 1, whatever that may be. Okay, it is usually denoted by sigma. So an alphabet sigma, that is nothing but a collection of symbols. Next, language. A language is a set of strings of symbols from some one alphabet. So here these languages are defined over some alphabet, right? Usually it is denoted by the letter L. So language is a set of strings which is defined over some alphabet, consists of either letters or digits, right? Next, the empty set pi and the set consisting of the empty string epsilon. Okay, so are languages. These are languages. Here you have to note that these two are different. Okay, both of them is not same, both of them are distinct, because the latter one has the member, this one has a member, whereas this one doesn't have any member. Okay, that is a difference. So let me now move on to an example. So for that, let me take the set of palindromes. You know what is the meaning of palindrome? Strings that read both same forward and backward over the alphabet consist of the digit 0, 1 is an infinite language, isn't it? Because L consists of first one you have to take epsilon. So set of palindromes you have to take 0, 1, 0, 0, 0, 1, 0. So if you read it both forward and backward, you can get the same string, right? And 1, 1, 0, 1, 0, 1, 1. Okay, like that 1, 1, 1, 2 you have to take. So whatever that may be, like that you can give so many different possibilities. So it is an infinite language. So another language is set of all strings over a fixed alphabet sigma. So we denote this language by sigma star. For example, if sigma consists of set of symbols only A alone, then sigma star is equal to set of strings of sigma A, like that. Next one is you can write it 4 times, etc. This is also an infinite language. If sigma consists of the set of symbols 0 and 1, then sigma star is equal to consist of set of strings of sigma 0, 1, different possible combinations between 0 and 1. You can list out 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0. Next one you can write 0, 0, 0, 0, okay, like 0, 0, 1. So if it is length 3 means you can start with 1, 0, 0, like that. So like that you can give so many different possible combinations. Next, let us move on to example. So let me describe in words the following languages over the alphabet. Here I have to take the alphabet instead of sigma by A. So A is equal to set consists of the symbols A and B. Okay. So first one, L1, the first language. L1 is consists of the set of all strings of the form A B square. What is the next one? A, B cube, etc. Which means how we are going to describe this language in terms of words. L1 consists of all words which begin with an A followed by one or more B's. Okay, this is how we have to describe a language. Let me move on to the second one, L2, the second language, so that I have to use the prefix. So L2 is equal to A power M, B power N, such that both M and N takes a value greater than 0. Okay, so how we are going to describe this in terms of words? So L2 consists of all words which begin with one or more A's followed by one or more B's. Next, let me move on to the third case. So L3. So L3 consists of the set of strings of the form A power M, B power M such that M greater than 0. Look at the power, both A and B have the same power. Look at here, both A and B have different powers. Okay. So here I have to write L3 as L3 consists of set of all words begin with one or more A's followed by the same number of B's. Okay. Next, let me move on to the last one. L4. L4 consists of the set of all strings of the form B power M, A, B power N with the condition that both M and N greater than 0, which means L4 consists of all words with exactly one A, which is neither the first nor the last letter of the word. Okay, this is not neither the first or the last letter of the word, and also there is one or more A's there are one or more B's and before and after A. Okay, so there are one or more B's before and after A, but that is both of them are not in same number. Okay, because both of them have the different powers here. So you got some idea about what is a language now. Let me move on to another example. In this example, I have to take K and L be two different languages over an alphabet A is equal to AB. Then what I am going to do is I have to combine. Okay, I just want to find KL and LL. Okay, the two languages. Okay, both here K and L are two languages which is defined over an alphabet. Here I have to name that alphabet as A. So here I have to find KL and LL. How we are going to find? Listen here. Here the order is very important. KL. What is your K? That is consists of A, AB and A square. And L consists of the strings of AB square, ABA. Now, what I am going to do is look at the word carefully. Concatenate the words in K with the words in L to obtain. Okay, you have to concatenate the word. Okay, not multiply. Right? So KL. So first you have to combine A with B. So AB square. Next A with ABA. So A with ABA, such way both of them are nearby portions, so that you have to multiply. So A square BA. Next you have to combine AB with B square. So AB and then B square. Right? AB and B square. So that you have to write this as AB cube. Next AB with ABA. So AB, ABA. So nearby portions are not same letters. So you have to write as it is. AB, ABA. Next you have to combine A square with B square. So A square, B square. Next A square with ABA. So A square with ABA means A square with ABA. So both of them are same letters. So in such cases you can multiply. Right? So A cube BA. So this is the language KL. Next concatenate. Next again one you have to find out LL. So in LL, concatenate the words in L with the words in L to obtain LL. So already you have L as B square ABA. Okay. So now we have to combine first B square with B square. So B power 4. ABA with ABA. So listen carefully. ABA. The last one is coincide with the here the first one, so that you can multiply. Okay. So AB A square BA, right? AB A square BA. Next, you have to take B square with ABA. So b square with aba, write it as it is. Next, aba with b square. So aba with b square, write it as it is. Okay, like that you have to give the four possible strings of the form like this. Next we move on to the next example. Consider the language L is equal to consist of A, B and C over the alphabet A consists of symbols A, B, C. Here you have to find, it's a very important thing here you have to notice that you have to find L power 0, L cube and L power minus 2. Okay. So here notice that you have to find the negative power of language. So the negative power of language is not defined. Okay, that is the answer. Only you have to, we have positive power start with 0. If it is L power 0 means consist of only the empty, that is empty set, that is epsilon alone. The set consists of only epsilon alone. Epsilon means the string has the length 0. Okay, the string has the length 0. So L power 0 means the language consists of only the string epsilon alone. Next, coming to the second one, L cube. So L cube means you have to, as previously I have to say, you have to concatenate L 3 times. That is L is equal to A, B, C. L is equal to A, B, C. A, B, comma, C. Right? So L is equal to A, B, comma, C. Right? First you have to concatenate L with L. With that answer you move on to again multiply that L square with L, which gives you the L language like this. Okay. So as what we did previously in case of LL and KL, that is what the same process here you have to carry out to find out the strings in that language. Okay. Right. You get the strings like this. So in my next video I will explain what is finite automata along with the examples. Thank you.